So the next type of thing that we need to look at today are what are called special right triangles. Now these triangles have some unique properties, some ones that we can kind of just know how the sides are related to each other in order to help us solve them. We certainly could still use the Pythagorean theorem, but we don't have to. They have some little shortcuts in them. And you'll see that these two types of triangles, this one here is what we call a 45, 45, 90 triangle. And the reason we call it that is because we have two angles that are 45 degrees and then one right angle or 90-degree angle. And any time that you see this triangle, our sides are always going to have certain properties where the lengths of those legs are, of course, going to be the same to each other, but then that hypotenuse will be that length times the square root of 2. So, for example, if we have a triangle and we're told that it is a 45, 45, 90 triangle, they may tell us that by markings, they might tell us that in words, they might label these angles as 45, but regardless, we know this is a 45, 45, 90. And so if we know one side, if we know that this side is equal to 7, even by just one side, we can fill in all of the rest. So we know that this side also has to be 7, right? Because those angles are the same, the side lengths across from them must be the same. But then, because of this special property, we know that this side is going to be 7 times the square root of 2. We could plug that into the Pythagorean and check it, but we know that that will always be true. Let's look at another one like this. What if we had, I'm going to draw my triangle right over in this space here. What if we had a triangle and we're told that it's 45, 45, 90. And maybe this time we know that this hypotenuse is 12 times the square root of 7. Pay careful attention to our properties up here, right? Because what we need to, oh, this isn't 7, this is 2. Let's make it nice and easy, right? So what we need to do is we need to fill out those other sides. Well, this already has that square root of 2, so we know that these sides must be 12, and it's going to fit that pattern. Okay, so this is the first of what we call a special right triangle, that 45, 45, 90 triangle. The second one that you'll see here is what we call a 30, 60, 90. And this is because, as you see in this triangle, we have one angle that's 30 degrees, one that's 60 degrees, and one that's 90. And so again, we have some special properties in here that say our shortest leg is going to be the length of S. Okay, and then the hypotenuse is going to be 2 times as long as that. And finally, our third leg, or second leg, right, our third side will be S times the square root of 3. Again, if we're given a triangle that has some sides, we can fill in those other ones. So let's look at an example here. You always need to know which angles are which. So here's our 30, 60, 90. And maybe in this situation, we know that this side here is 6. Now pay careful attention here because it's the one between the 60 and the 90. And so if I look at my example and find that side, then this is going to be our S value. So if I know that that is my S value, I can follow my pattern. Well, 2S is 12. And this last side is going to be 6, or S, times the square root of 3. Again, use the Pythagorean and check it, but otherwise, by these relationships, we can know it. Let's do one more example. Here's our 90, here's our 60, and our 30. And this time we know that this is 9 times the square root of 3. I want to be really careful. I know my length between the 30 and the 90 here, this should be s times the square root of 3, right? And because they basically match, we can then see that s is 9. And so we're going to use that to fill in our other sides. So here's a 9 and here's an 18, right? And we can find the other sides. Again, this one is called a 30, 60, 90 because the angles are 30 degrees, 60 degrees, and 90 degrees.